All right, what are differential equations? What are differential equations? Got an equal sign, got a derivative, and a function, okay? So something that's got derivatives in it and it's an equation. So we solved differential equations yesterday some. What did we do to solve differential equations yesterday?
Say it equals, or we took
No. Integrate, yes, we integrate. When we solve differential equations, there's two types of solutions we can get. What are those two types of solutions? Y'all remember the two types of solutions we can get? General and particular. How do you find a particular solution?
You have points.
You got to have a point to plug in, and you can solve for the C. What are slope fields?
Show the trend of slope.
Graphs with a whole bunch of slopes on them, and we talked about how to find slope fields yesterday. Today we're going to talk about solving differential equations, and this is an example of one right here. Tell me, when you look at this differential equation here, what's different about it than what we've been dealing with? Okay? It's got an equals in it, but if you look back at 35, you'll see that this one has one thing that's different from any other equation you've ever had. It's got a y and an x in there. Normally we just integrate, right? Well, if we're integrating, which one do we integrate with respect to, the y's or the x's? So, here's the goal for this. When you're trying to solve differential equations, specifically some that have x's and y's in them, you want to go through and separate the variables. What do we mean by separate the variables, you think? Okay. Yeah, we need to separate. What does it mean to separate things? Just in general. If I have to separate you two for talking, what does that mean I got to do? Split you apart. So we're going to do the same thing here. We're going to separate the variables. Now, it's rather important that you do this the right way, okay? First thing you want to do is, instead of y prime, we can write this as dy over dx. And let's try that. Let's try that again, since we're off by about 6 inches here. All right, let's try that again. So we're going to rewrite this as dy over dx equals 2x over y. And what did we call dy yesterday? Anyone remember?
Y.
Derivative of y. It's also the differential of y. We want to think of this right here not as one complete quantity dy over dx, but think of it as the quantity dy divided by the quantity dx. So we can separate those things out. So what we want to do is we want to separate everything that has y's and dy's on the left. Everything that has x's and dx's on the right. Okay? So if we multiply this times this, we get y dy over here. And on this side, we will get 2x dx. So now, would you say we have separated a variable? We've got x's and y, x's on one side, y's on the other side. Now, what do you think we need to do to solve what you see? We need to integrate. So we're going to integrate the left side and the right side. When we integrate the left side, we integrate with respect to y. Why? dy. dy. So when we integrate y with respect to y, what do we get for that integration? Y squared over 2 equals, what do we get when we integrate 2x with respect to x? X squared. And we're going to put a plus c. Where do we put the plus c at? Doesn't really matter. It's on one side or the other. Remember we talked yesterday, really technically we've got a plus c on each side. But then we can combine those c's together into one c. So as long as you put a c somewhere. Now, how could that be written with no fractions? All right, so another way you would need to be able to recognize this answer is y squared equals 2x squared plus c. Why is it not 2c? That's right. 2 times this letter c up here gives us this letter c down here. So it's still a constant number there. It wouldn't be wrong to write it as 2c. But that's all we do when we separate variables. We want to get all the y's on the left, all the x's on the right, and then integrate both sides. So it's a simple process, but you have to think clearly what we're going to wind up doing here. For example, looking at this one, dy over dx equals 6 minus x. So we're going to multiply over, and we get dy equals 6 minus x dx. Well, we don't have a y. That's right. There's an understood 1 there. So when we do go through and when we integrate the left side, we get a y then. And when we integrate 6 minus x, we get 6x minus x squared over 2 plus c. Does that seem logical to everyone? And we could multiply both sides by 2 and we get 2y. There's no standard way that you need to be able to write these. You need to be able to recognize either of those answers mean the same thing. Bottom line, you need to be able to recognize that. Well, let's look at a few more problems here. I said forward. Well, that one doesn't want to work, so this one up here will. Now, that's almost the same problem, isn't it? Why is it different? Because it's got a y. So what happens if we do just what we did before? Cannot add a y. All we can do is multiply or divide, because think of this as a quantity here. So we're going to divide both sides by 6 minus y. So we'll have 1 over 6 minus y dy, and you could write it as dy over that, equals dx. All right? Now we need to integrate. The right side's easy to integrate. What do we get on the right side? X. All right, so we get x over here. Very good. ln 6 minus y, absolute value, plus c. We missed one thing there. Why negative? All right, and this, Katie did a lot in her head here, and it's fine for you to do that. Just be sure you don't mess up here, because what did you really do here? In my head, I said let u equals 6 minus y. So du is negative dy. So negative du equals dy. And then I went through and integrated, okay? Don't forget that negative sign here. So we've got negative ln of that equals x plus c. All right? Solve for y. I want y equals. It's not multiplied by e's, but yes, you've got to exponentiate each side. Does that word ring a bell to you? Okay? If you go back, way back in time, when you first learned about logarithms, we wrote down something that looked like this. ln of x equals y means that e to the y power equals x. So that's what we've got to do. We've got to change this from logarithmic form to exponential form. So what I'm going to do is I'm going to change. First thing I want to do is get rid of that minus sign. I can do it this way. Equals negative x minus c. Agreed? Right, so we're going to say e to this power over here, negative x minus c, equals 6 minus y. That's just using the definition here. We said the base e to this power here equals the argument, 6 minus y. Now, we wanted to get y by itself, so what do you want to do to solve that, figure that out? Good question. Does the 6 minus y have to be absolute value anymore? The answer is no, it does not. I can't really give you a great explanation for that, but just no, it does not, okay? So now we need to get y by itself. I'm going to wind up with y equals 6 minus e to the negative x minus c. All right? Now I'm really going to work some magic here. And this is y equals 6 minus 6 minus c e to the negative x. That's what your final answer should look like. What is right? How did we do that? No, you can't bring down the exponent. You can't. Well, you can't do that either. Let's take a side note here for a second. This is really the same as e to the negative x times e to the negative c. Because when you multiply, you add the exponents together, right? Well, c is a constant number, right? E is a constant number. What's a constant number to a constant number? It's going to give us a constant number. So we normally write it like this. Y equals 6 minus c e to the negative x. So that's the final answer you'd want to work to with something like that. So exponentials, you're going to see exponentials and LNs in differential equations quite regularly. So expect it. All right, let's look at another problem. I can? The algebra can mess with you here, so be careful with your algebra. Yeah, we'll look at the next one. What is it? Well, let's see. What do we need to do? Solve by separating variables. Yes, we need to solve this by separating the variables out. So we're going to do the same thing as we've been doing. See if you can get started. Then I'll jump in there when I need to. Did I take attendance? I did. Okay, so here we have 7y dy equals x to the 1/2 dx. So if we integrate over here, we get 7/2 y squared equals 2/3 x to the 3/2 plus c. And yes, I did a lot of that in my head, but hopefully you can get there. If I need to go back and do some other stuff on the board, I can. I think that would be our answer. Yes.
3y squared, and then 4x.
Ooh. Let's see. All right, so I'm going to integrate both sides here.
So you didn't do like,
Yes, you could multiply by 6 if you need to. No, we'll see, get something different here.
is y prime the same as dy?
Yeah, y prime, remember, we want to change y prime and rewrite that as dy divided by dx. That way we've got separate differentials. We can get dy's on, everything with y's on the left and everything with x's on the right. And we raise one power and divide by that power, which flips it over and makes it become 2/3 x to the 3/2. All right. Yeah, I'm trying to think here for a second, because I'd get 21 and 4. Yes, that'll work. So I could wind up with 21y squared equals 4x to the 3/2 plus a c. Now, how did we get there? You've got several ways of thinking of that. I just took this whole thing and multiplied it by 6. That gets rid of my my fractions. Getting rid of fractions makes it look nicer most of the time. So we get 21y squared equals 4x to the 3/2 plus c. I think that would be an acceptable final answer there. Okay? Well, let's look at another one. See if we can find something challenging here. Now, let's keep moving. Y'all can do that. We might come back to that later. This one looks like fun. Solve by separating variables. X, y plus y prime equals 100 over x. Well, where are you going to start? All right. All right. Let's change. Let's talk about what we want to do here. We know we need to do that just to get our naming conventions right. So I heard somebody say divide by x. Well, if I divide this by x, I get y, but then I've got dy over dx divided by x. That looks ugly. Also, look at this. I've got this x and y don't even have a dy or dx with them. So what I would do is I would subtract xy from both sides. So we get dy over dx equals 100x minus xy. Now, yes, I think that's what I would look at, because remember, what are we trying to get to? If it's got an x in it, we want it on the right side. If it doesn't have an x in it, we want, or if it's got y's in it, we want it on the other side. So I would factor an x out of this and get x 100 minus y. Yep, so now I can do my cross multiplication mess. I can get 1 over 100 minus y equals x dx. Is that too much in my head? Yep, I should be a dy there too. Okay, there should be a dy right there. So let's see what we've got here. I've got dy equals x times 100 minus y times dx. That's just getting the dx, so I don't have any fractions there. But now I've got this y term over here on the right with next to the dx. So I need to divide by it. And if I divide the right side, I need to divide the left side. And I wind up with this bottom line here, 1 over 100 minus y dy equals x dx. Now you should think, okay, I can integrate. You've been integrating enough, and hopefully you're saying, wait a minute, I saw something like that a while ago. That becomes negative ln of 100 minus y equals x squared over 2 plus c. But what if we want to solve that for y? How can I say?
E to the x squared over 2.
Plus c, but then what can we do with that minus sign? We could do that.
Move it to the
Let's move the minus sign over and then do that. Equals negative x squared over 2 minus c. So this becomes e to this right-hand side power, e to the negative x squared over 2 minus c equals 100 minus y. And now we want to get the 100 over there and change the signs. We want to get y by itself at this point in time. I'm going to say y is 100 less e to the negative x squared over 2 minus c.
Would you change it to minus 2 as well? No, there's no minus 2.
Does the sign really matter?
No,
You don't know. I mean, so if you say c is, if you say it should be plus 5 e to the negative x squared, I can say it's supposed to be minus negative 5. So we're at the same place there. So the sign is not that important there as long as you've got the c already moved to the bottom. But I caution you, you have to be careful with these because you've got to be sure that mathematically what you're doing is sound. All right? The one thing I don't want you to think of, I'm not just taking this minus c right here and moving it to the denominator. This minus c up here is a totally different number than this c we've got down here. Totally different number. This c down here is really e to this c number up here, whatever it was. I know that's confusing to you. Smart teacher would be using different numbers, but I haven't been accused of different letters, but I haven't been accused of being smart lately. So y equals 100 minus c e to the negative x squared over 2. Okay, we're going to come back and let you do some more, but I want to move forward and try to find something else to play with here. No, we'll save that. Move all the way to this slide, whatever slide this is. This is slide 11, okay? Because this scares people. Has words in it. Doesn't have anything that looked like what we've been dealing with. Write and solve the Diffie Q. The rate of change of Q with respect to time. What does that mean? How are you going to write that? dq dt. Actually, it should be a capital Q since we had a capital Q there. dq dt is inversely proportional to the square of t. Inversely proportional.
1 over t squared.
All right? And it's actually k over t squared. Why is it k and not just 1? Because there's something called a constant of proportionality. You go back and remember from somewhere along the lines, you've learned that. So that's our differential equation. dq over dt equals k over t squared. So we've written it, now solve it. What do we do? It's a good question. We're going to cross multiply, so we would have, actually let's just do this. Let's say dq equals k over t squared dt. Why do I not want to cross multiply the t squared over and get, because we know we got to bring it right back over there. So now we've got the q's over there, t's over here. What about that k? It's a constant number, so it's just a number in there, okay? What do we need to do now? We just need to integrate that bad boy. Q equals, now how are we going to integrate k over t squared? Bring the k to the outside, so we can make it k integral 1 over t squared dt. How are we going to integrate 1 over t squared? That's what I was afraid somebody's going to say.
bring the squared up.
Yep.
To the negative.
Yep, that's a very, very, very common thing that people want to do. Is it's a fraction, so we're going to have LNs in it. Remember, this is k t to the negative 2 dt. Now integrating that's a little different. We see it a little differently. How do we integrate t to the negative 2? Negative 1 over negative 1, isn't it? T to the negative 1 over negative 1. So we get, find out that then that becomes Q equals K over T. There's a negative sign somewhere. Q equals negative KT plus C. Oh, we got KC. Hey, DQ and KT. Mr. Meeks, they're trying to convince me that since we're studying Diffie Qs, we need a field trip to Dairy Queen for Diffie Qs.
You can join. We'll go there in this
That's a good argument there, isn't it? So, okay, so
That's why God made that.
to get us to DQ, Katie, wow, Katie, okay, all right, good. Okay, so does this feel comfortable to you? I'm not dismissing the DQ yet. Okay, so just don't lose me yet. Is this comfortable with everybody? All right, so let's keep moving because there's some others that are going to freak you out. You can handle that, and I'm going to let you come back and do that. There's too many words there. This is what I want to get to. In exercise 7.2, find that y equals f of t passing through the point 0, 10 with the given first derivative. Use a graphing utility to verify. You can do that. I'm not going to waste our time there. Where's the one I'm looking for? That's what I want to look for, okay? This has more words in it. So I'm all the way to 16, all right? Write and solve the Diffie Q that models a verbal statement. That's what we just did. Evaluate the solution at the specified value of the independent variable. Okay? So let's focus on the first part first. The rate of change of y is proportional to y. dy, dt, dx. Which should it be? dx's or dt's? Y-x's. Because we got x's. dy dx is proportional to y. What do we need to write? Equals ky. Ky, because it could be a constant of proportionality in there, okay? So now solve that problem. You can solve that. I have confidence in you. Now, do y'all want to take the, I need a show of hands. Are we going to do this? Or are we going to do 1 over ky? 1 over ky, is that what most people did? It's not, there's not a wrong or right answer necessarily, okay? It's just, what you're going to get is going to look a little differently depending upon what you do there. So, all right, we're going to leave the k down here. All right, so now we're integrating. So what happens when we integrate? We can take out a 1 over k. So we're 1 over k, integral of 1 over y. What does that become for us? ln of y with a 1 over k out in front, right? What does this other side become? X plus a c, right? All right, now, I can go ahead and tell you most of the time if we've got LNs, we want to wind up getting it to ease. It just makes life easier. So what do we need to do with this to get it to ease? No, we need to get rid of that 1 over k first. Let's multiply both sides by k. So we get ln of y equals kx plus c. And yes, I did multiply it by k, but I'm just kind of forgetting about that, okay, because it's just a constant. And now we could say e equals kx plus c equals y. Excuse me, I said that wrong. E to the kx plus c equals y. Yeah, so y equals c e to the kx. Y equals c e to the kx. Have you seen that before? Huh? Doesn't spell anything? Does pert ring a bell to you? Not the shampoo. Yeah, pert rings a bell. I can tell by the scowls on your faces. P e to the RT. Okay? Same type formula here, okay? So that's the reason I said, does it ring any bells to you? Now, so we've done the first part. Now, what does all this gobbledygook down here say? Really, it's saying, figure out what C and K are. That's what we need to do. Figure out what C and K are. So what do we know? When X is 0, Y is 6. So let's figure out what that gives us. X equals 0, Y equals 6. So if we plug that information in here, let's see what we get. We get 6 equals C e to the k times 0, right? E to the 0 is 1, so we get C is 6. Woohoo! We figured out what C is. So now we can change our equation. Y equals 6 e to the kx. You agree with that? Now let's go. Well, but we need to know what k is. When x is 4, y is 15. So now we can put that information in. X 4, y is 15. We can say 15 equals 6 e to the 4k. Ooh, what can we do there? Divide by 6. We can get 15 over 6 equals e to the 4k. But we need k, peoples. ln both sides. We get the ln of 15 sixths equals the ln of e to the 4k. How does that help? That just becomes 4k. So we get the ln of 15 sixths equals 4k. Divide by 4. So we get k equals the ln of 15 sixths divided by 4. That's an awful, ugly number, isn't it? That's all right. It can't help it. So now what have we changed our equation to? We said y equals 6e to the ln of 15 sixths divided by 4 times x. All right, yeah. All we've done so far is figured out what the equation is. So now, what's the real question at the end there? It says, what is the value of y when x equals 8? Now we're going to plug in 8 for x and go from there. So we get y equals 6e to the ln of 15 sixths divided by 4 times 8. And I would never pick up my calculator until maybe at this point here, okay? Yes, you'd be able to use your calculating device for this, but if you do any rounding up here for C or for K, you're going to mess up your answers down here. So I'm going to continue cleaning this up as much as I can. That becomes 6e to the 2 ln of 15 over 6. Would you all agree with that? All right. And now I would probably pick up my calculator if I were you. I mean, I can do this here. 15 over 6 squared. Raising a power to a power, I multiply the exponents. And what's e to the ln of something? Anybody remember? No, e to the 1, no, what if I E something and then ln it? It's kind of like squaring and square rooting it. So this just becomes 15/6 squared. Whoops. Okay. That says e to the 2 times ln of 15/6. X to the 2 times 3. X to the 2 times 3. That's the same as x cubed squared. When I'm raising a power to a power, if I'm raising a power to a power like this here, I can just multiply the powers together like that. So that's what I did here. Now I could get 225 over 36 times 6, which becomes 225 over 6, which I don't know what that becomes. But now, I do not expect you to be able to do all of this. If you can get to this point right here, let's do it in a different color. If you can get to that point right there, don't feel bad about picking up your calculating device and calculating. And you'll get the same answer I did down here eventually. 30-something. All right? I'm doing e to the ln of a power. E and ln are inverses of one another, so if I take the ln of something and then raise it to the e power, I just get back to where I started from. Okay, how does that feel? Separating variables, what does that mean? Your dy's and y's over on the left, x's and dx's on the right. Have you noticed that I've been saying get the y's to the left every time? You need to do it that way. Because what happens if I tried to move the y's to the right side? Well, what would happen to the d? What would I have to do to the dy to get it to the right side? Divide. And dividing by dy, remember, we don't know how to integrate if dy is in the denominator. So you want your dy on the left side. That's all I've got to go over with for you today. Probably on Thursday morning, we're going to come back and review some of these same things. Go over these either Thursday or Friday. Here's my thought right now. We're going to do these on Thursday, and I'm going to have just 3 or 4 problems for y'all to do on Friday as an in-class on-paper quiz. The rest of the week is going to be yours, so you'll have tomorrow to work on test corrections, WebAssign, FRQs, video problem. You'll have at least 1 hour on Friday to work on whatever you need to, okay? Yes? When's the video problem? Tomorrow night.
Thursday night.
Yeah. WebAssign tomorrow night, FRQs, WebAssign tomorrow, video Thursday, FRQs Friday. And test corrections Friday, okay? I think we're going to have a quiz on Friday. That's